Though the reality of doing this is very low, because it would result in the entire observatory requiring recalibration and would set back scientific study greatly. It is more likely that NASA would also just accept the flaws for the greater good of the project. Finally, NASA prepared the last instrument, the mid-infrared instrument. This one was last because it was on the other spectrum of the last three instruments and was nowhere near its ideal operating temperature. MIRI required both a repositioning of the Webb as well as a boost from a cryocooler in order to get to its ideal chilly resting spot. This instrument provides imaging, coronagraphy, and important field spectroscopy for wavelengths that are longer than our eyes can see. Not one for the Sun, it is a great instrument to study in the next and final round of tests for this powerhouse observatory. Right now, the JWST is engaging in its thermal stability test. The goal of this gauntlet is for the telescope to endure the changes and to prove it can work optimally in spite of conditions. While being closely monitored, it will be exposed to varying degrees of sunlight, causing the observatory to swing through a range of temperatures. Scientists at NASA will be closely inspecting the observatory's instruments to measure their performance, calibration, and overall operations. These instruments are unique and each was carefully chosen, so the stakes are very high. Dripping with astronomical sweat, the Webb telescope will begin the thermal stability test by adopting a hot attitude of about 0 degrees pitch for 5 days. Heating up and then stabilizing thermally, the scientific team at NASA will take the instruments through a barrage of tests to simulate possible scenarios in the extreme environments. After the heat, for another entire week, the telescope will be plunged into freezing temperatures at plus 45 degrees pitch from the Sun. After stabilizing there, it will rotate to minus 5 degrees to the Sun and heat back up. At both attitudes and throughout the transition, the instruments will be closely monitored. The team will be utilizing the telescope instruments to better understand how they operate at each extreme and in between. The importance of acclimatizing the observatory to all extremes is very apparent, because some of the instruments were made specifically to perform best at certain temperatures. For example, examining the infrared universe requires that the telescope and instruments be cold. Thus, scientists want to know how it operates at higher temperatures to study it in both optimal and suboptimal conditions. That sounds like an understatement though, as in space, the difference is quite extreme, with the observatory experiencing a change of 126 degrees Fahrenheit to negative 384 degrees Fahrenheit from the hot to the cold side. That fact puts suboptimal conditions into a better perspective. In order to complete the commissioning of the James Webb Telescope, all of the instruments must have detailed measurement of their performance taken. This will happen as it oscillates through the spectrum of temperatures as well as afterward, hopefully maintaining its same image quality and pointing ability throughout. Let's explore just a few of the tests that Webb will endure throughout its last 2 months of preparation. Firstly, the scientists will be measuring the throughput of the instruments. Throughput is how much of the light entering the telescope actually reaches the detectors to be recorded. There is some loss as it bounces through the mirrors, and it's impossible for every photon to be detected. As it is normal, they want to account for and adjust the sensors appropriately. NASA will also study Webb's capabilities to observe moving targets. For example, they will focus on and follow asteroids of varying speeds to make sure it is performing up to their high standards. Next, they will focus on the astrometric calibration of all of the maps that each instrument has. Astrometric calibration is the mathematical process of translating the positions of image pixels to the coordinates of the stars in the sky. This is important as it will help with the navigation and plotting of the transmitted data in the future. NASA will also be measuring the point spread function, or the sharpness of the images that are transmitted to the scientists. They have already calibrated the main mirror to get clear images, but each instrument has sub-abilities. Some such abilities are filters that collect color information and diffraction grafting to slice the incoming light into its proper color category. All of these abilities must be tested so that there is an official baseline of quality. Even billion-dollar space projects are subject to routine quality checks. There are only 2 months left before the James Webb Space Telescope is fully functioning and ready to stare into the heart of the universe. But there are still a lot of tests between now and then. How do you think the JWST will perform throughout this gauntlet? Let us know your expectations down below. Don't forget to like and subscribe for more videos like this, and thank you for watching Factnominal.
For years now, the close study of transiently accreting neutron stars has proven to be a powerful method for really studying and understanding the core properties of these stellar corpses. While studying one such neutron star at the edge of the Milky Way, astronomers made a shocking discovery. Astronomers believe they found evidence of an extremely powerful thermonuclear explosion in space, unlike anything we've ever seen before. Welcome back to Factnominal, and today we're going to take a look at this gigantic explosion, one so rare that we're unlikely to ever see it again. There are so many different types of stars scattered all throughout the universe in various shapes, sizes, and varying luminosity, right from red dwarfs to bright giants. Among these, neutron stars are some of the most unique and important stars in the vast expanse of space. When stars that are about 4 to 8 times larger than our Sun use up their hydrogen supply over time,